Now, in this lecture, we find out the ratio between two radii. In the drawing, we have the big circle. Inside this big circle, we have two small circles. And we know that the radius of this circle is B, and the radius of the small circle is A. Inside the big circle, we have the right triangle ABC that is partially located inside the big circle. We also know that the length of side AB is equals to 5 units, BC equals to 12 units in its length, and we also know that this angle ABC equals to 90 degrees, and we also know that AN equals to NC. Our mission is to find out the ratio between the radius of this circle and the radius of this circle. That is to say, the ratio of B over A. So first of all, we implement the Pythagoras theorem on this right triangle, triangle ABC. So according to the Pythagoras theorem on the right triangle ABC, by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle ABC, the hypotenuse is AC, therefore AC square equals to AB square plus BC square. Which again, according to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So AC square equals to 25 plus 144 is 169. We take out of this equation, and we get that AC equals to the square root of 169, that is 13. So the hypotenuse AC of the right triangle ABC equals to 13 units in its length. At point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So we can find out that AC over 2 is actually 13 over 2. It is equals to the first half is AN and the second half of the hypotenuse AC is NC. So we found out that AN equals to NC equals to 13 over 2. So you can write down here that the second half NC equals to 13 over 2 units in its length. In the next step, I present to you a new rule number 8, and we'll implement rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by right triangle is equal to R equals to A plus B minus C over 2. We have the right triangle ABC, angle ABC equals to 90 degrees. The length of side AB is A units, side BC equals to B units is length, and the length of the hypotenuse AC is C. Again, the radius of this circle is R. According to this rule number 8, we can actually calculate the radius of a circle that is blocked a right triangle only by knowing the side lengths of the right triangles that blocks the circle. That is to say, the radius of this circle R will be equal to A plus B minus C over 2. Again, the radius of this circle R equals to A plus B minus C over 2. So you can actually implement rule number 8 in our drawing. In our drawing, we have the right triangle ABC. This right triangle ABC blocks this circle, and the radius of this circle is A. According to rule number 8, we get that A, the radius of this circle A, will be equal to AB plus BC minus AC over 2. Again, A equals to AB plus BC minus AC over 2. So A equals to AB, that is 5, plus BC, that is 12, minus AC, that is 13 over 2. So in total, we found out that A equals to 5 plus 12 minus 13 over 2. This is according to rule number 8. 5 plus 12 is 17. 17 minus 13 is 4, and 4 over 2 is 2. So in conclusion, we found out that A, the radius of the smallest circle, equals to A, that is equal to 2 units in its length. Here, this radius A equals to 2 units in its length. In the next step, we define the center of this circle as P. We define the center of this circle as Q. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. Point P is the center of the circle, point T is the point on the circle itself. Therefore, PT is the radius of the circle that is equal to A, and A equals to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AT. If the circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. This is according to rule number 1. We define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees. This angle also equals to 90 degrees. So in quadrilateral PTBN, we have 1, 2, 3 right angles. The sum of right angles is 90 times 3 is 270 degrees, plus the missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles in quadrilateral PTBN to 360 degrees, the missing angle must be equal to 90 degrees. So quadrangle TPBN is 4 right angles, and quadrangle that has 4 right angles must be this rectangle if not a square. So we relate to quadrangle TPBN as a rectangle, and we know that the opposite sides of rectangle are equal to each other. That is to say TP equals to BN, but TP is 2, therefore BN must be also equal to 2. Likewise, in rectangle TPBN, PN equals to TB. But Pn equals to 2, therefore Tb must be also equals to 2. So we found out that quadrangle TPBN is not a rectangle, but a square. Why? Because all of its sides are equal to each other. So it is given us the equation that VA equals to 5. We just now found out that TB equals to 2. Therefore AB minus TB equals to 80. Again, AB minus TB equals to 80. So AB is 5, TB is 2, 5 minus 2 is 3, so 80 is 3. And we have here rule number 2. The lengths of two tangents from a common standpoint to a circle are equal. We focus on the common standpoint, point A. From the common standpoint, point A, we have two tangents to the circle, tangent AT and tangent AM. And according to rule number 2, they must be equal to each other. That is to say, AT equals to AM. But AT is 3, therefore AM must be also equal to 3. We have already found out that AN is 1/2 of the hypotenuse AC. AC is 13, therefore AN is 13 over 2. So AN is 13 over 2, AM is 3, so AN minus AM equals to MN. Again, AN minus MN equals AN minus AM equals to MN. I write it down. AN minus AM equals to MN. Repeat again. AN minus AM equals to MN. AN is 13 over 2. AM is 3. Here we multiply by 3 by 2 and then we divide it by 2 in order to overcome factor with 13 over 2, and we get that 13 over 2 and 3 times minus 3 times 2 is minus 6. 13 minus 6 is 7. So this expression total equals to 7 over 2. So we already found out that Mn equals to 7 over 2. Mn equals to 7 over 2. This line segment Mn equals to 7 over 2 when it's in its length. Okay, so in the next step we define the center of the biggest circle, this point is O, and I will present to you a new rule number 7. We will implement rule number 7 in our drawing. Again, point O is the center of the biggest circle. Going to rule number 7, if a line segment that is drawn from the center of a circle bisects a chord, then the line segment is perpendicular to the chord. The center of this circle is here at point O. Line segment OM bisect chord AB. That is to say, AM equals to MB. And whenever you have line segments from the center of a circle that bisect the chord, it must be also perpendicular to the chord. So in this case, OM is perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 7. Again, whenever a line segment from the center of a circle bisects a chord, it must be also perpendicular to the chord. Because OM bisects chord AB, this says that AM equals to MB, therefore OM will be also perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 7. So here We can implement rule number 7 in our drawing. We join points O and N together by a set line. Point O is the center of the biggest circle. From the center of the biggest circle, we have line segment ON that bisect chord AC. Why line segment ON bisect chord AC? Why? Because AN equals to NC. Okay, so therefore ON bisect chord AC. And according to rule number 7, whenever you have a line segment from the center of a circle that bisects a chord, it must be also perpendicular to the chord. Therefore, line segment ON must be perpendicular to chord AC. That is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 7. So, in conclusion, we can write down that ON is perpendicular to AC. So I write it down here. ON, line segment ON is perpendicular to tangent AC or chord AC. Point Q is the center of this circle, point N is the point on this circle itself, therefore Qn is the radius of this circle is equal to B. Qn is the radius of this circle. Point N, AC is tangent to the circle. N is the point of tendency of tangent AC with this circle. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down that Qn is also perpendicular to AC. Qn is perpendicular to AC. And from those two equations, Qn perpendicular to AC and ON perpendicular to AC, we will derive that point O must be located on the radius Qn. Is located on the radius Qn. This is point O, that is the center of the biggest circle, is located on this radius Qn, the radius of this circle. Or if point O is located on Qn, it means that Qon is one straight line. Qon is one straight line. Line segment Qon is one straight line. This point, this circle touches the biggest circle. This is the point of tendency between the two circles. We define the point of tendency as U, and then we draw tangent VW. Tangent VW is tangent at point U to both circles, to this circle and to the biggest circle. So here point Q is the center of this circle, point U is the point on the circle itself, therefore QU is the radius of this circle that is equal to B units in its length. The radius QU is drawn to point Q, that is the point of tendency of tangent VW with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius QU. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So you can write down that QU is perpendicular to VW. QU, the radius QU, is perpendicular to tangent VW. In addition, point O is the center of the biggest circle. Point U is the point on the biggest circle itself. This is exactly the definition of radius. So OU is the radius of the biggest circle. We define the radius of the biggest circle as x. So the radius OU of the biggest circle is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. If VW is perpendicular to UO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. So I can write down also that OU is also perpendicular to VW. OU is also perpendicular to tangent VW. And from those two equations, QU is perpendicular to VW and OU is also perpendicular to VW. We will derive that OQU is one straight line. OQU, line segment OQU is one straight line. That is to say, all the 3 points O, Q, and U are located on the same straight line. Otherwise, if, for example, point Q is not located on OU, either OU will not be perpendicular to VW, QU will not be perpendicular to VW, or OU will not be perpendicular to VW. All the 3 points O, Q, and U must be located on the same straight line in order that the both OU will be perpendicular to VW and QU will be also perpendicular to VW. Okay, so derive from it that OQU is one straight line. So we actually found out that OQU is one straight line and QON is also one straight line. And from those two statements, we derive that NQU is one straight line. Because of the fact that QON is one straight line and OQU is also one straight line, we derive from it that NQU is one straight line, NQU, I say that NQU is one straight line, if NQU is one straight line, it means that NU is also a straight line. NU is a straight line. NU is a straight line. But NU is a straight line that touches the circle at point N and U. Therefore, NU is a chord that passes through point Q, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. And therefore NU is the diameter of the circle. NU is the diameter of the circle. But the radius of this circle equals to b. Therefore, the diameter of any circle is twice as long as the radius. Therefore, nu, that is the diameter of the circle, must be equal to 2b. Nu equals to 2b. In the next step, we will join points O and P together by a straight line. Point O is the center of the biggest circle, point P is the center of the smallest circle. The smallest circle and the biggest circle have an internal length between them. At this point, that is to say, they are touching each other internally at point S, this point. And here we have hole number 9. According to hole number 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. The center of this big circle is here at point O, the center of this small circle is here at point M. The straight line that connects the centers together is the straight line OM. According to this rule number 9, the straight line OM must pass for point P, or OMP is one straight line. Again, OMP is one straight line. We can implement rule number 9 in our drawing. Why? Because in our drawing, the smallest circle touches the biggest circle at point S. Therefore, according to rule number 9, the straight line that connects their centers together, that is to say, the straight line OP, must pass for point S. That is to say, OPS is one straight line. You can write down that OPS is one straight line. So if OPS is one straight line, it means that SO minus SP equals to PO. Again, SO minus SP equals to PO. I'll write it down. SO minus SP equals to PO. What is the definition of line segment SO? By the way, if SPO is one straight line, it means that SO is also one straight line. Okay, SO is a straight line. What is the definition of the straight line SO? The straight line SO starts from point O, that is the center of the biggest circle, and ends at point S, that is the point of the biggest circle itself. This is exactly the definition of a radius. So SO is the radius of the biggest circle, that is equal to x. So we substitute SO in this equation by x minus SP. We've already found out that SP is the radius of this circle, that is equal to 2. So we can substitute SP by 2. So in conclusion, we found out that PO equals to x minus 2. PO equals to x minus 2. This line segment PO equals to x minus 2. In the next step, we will extend the perpendicular ON by a straight line to point T. ON is a perpendicular, it is absolutely a straight line. When you extend this line ON by a straight line, the result is OT. When you extend the straight line by a straight line, the result must be a straight line, so OT is a straight line. if OT is a straight line, we focus on this side of the straight line OT at point N. And this side of OT at point N, the sum of the angles must be equal to 180 degrees. For which angles we have at this side of OT at point N, we have this angle that is equal to 90 degrees. Plus the missing angle, in total must be equal to 180 degrees, according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. According to the rule that I mentioned, the missing angle must be equal to 90 degrees. We also know that CA is tangent to this circle at point M. We join points P and M together by straight line. Point P is the center of this circle, point M is the point on this circle itself. Therefore, PM is the radius of this circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees. In the next step, we'll do a construction. We'll draw perpendicular on the radius MP at point P. Again, we'll draw perpendicular on the radius MP at point P. So actually, this angle equals to 90 degrees according to our construction. So in quadrilateral NMPT, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Quadrilateral NMTP that has 4 right angles must be a rectangle and flat square. So we relate to quadrilateral NMTP as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, PM equals to TN. But PM is 2, therefore Tn must be also equals to 2. We define the length of line segment NO as H. In rectangle MNPT, MN equals to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. In the next step, we will implement the Pythagoras theorem on the right green triangle POT. So I copy the right green triangle POT in a new page and we implement on it the Pythagoras theorem. We have already found out that PO equals to x minus 2, so the hypotenuse PO is x minus 2. We just now found out that PT is 7 over 2. Here, the perpendicular PT is 7 over 2. And finally, what is the length of OT? On the drawing it is very easy to see that OT equals to ON plus NT. That is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. TO equals to H plus 2. So according to the Pythagoras theorem, in the right triangle OPT, PO square equals to PT square plus OT squared. PO is x minus 2, therefore PO squared is x minus 2 squared. Is equals to PT squared. PT is 7 over 2, therefore PT squared is 7 over 2, that is 49 over 4, plus OT squared. OT is h plus 2, therefore OT squared is h plus 2 squared. We'll open the brackets on both sides of this equation, and we'll get that x minus 2 squared equals to x squared plus 2 squared, that is 4, minus 4x, that equals to 49 over 4, plus h plus 2 squared is equals to h squared plus 2 squared, that is 4, plus 4h. Okay. In the next step, we'll join points O and C together by a straight line. What is the definition of line segment OC? Line segment OC starts from point O, that is the center of the biggest circle, and then the point C, that is the point of the biggest circle itself. This is exactly the definition of a radius, OC. So OC is the radius of the biggest circle, that is equal to x. ON equals to h according to our definition, and we already found out in the beginning of the lecture that here NC equals to 13 over 2. So I copy the right triangle ONC in your page, and we will implement on it the Pythagoras theorem. The hypotenuse OC equals to x, ON equals to h, according to our definition, and we already found out that NC equals to 13 over 2. So according to the Pythagoras theorem, on this right triangle ONC, you get that OC squared equals to ON squared plus NC squared. OC is x, therefore OC squared is x squared, so x squared equals to ON squared. ON is h, therefore ON squared is h squared plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared, that is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. Therefore, we can substitute x squared in this equation here by h squared plus 164 over 9. We'll do it now, and we'll get that x squared is h squared plus 169 over 4 plus 4 minus 4x is equals to 49 over 4 plus h squared plus 4 plus 4h. Here we have h squared on both sides of the equation, so h squared will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. We left only with 169 over 4 minus 4x, that is equals to 49 over 4 plus 4h. Here we subtract 49 over 4 for this equation, and we get that 169 minus 49 over 4 minus 4x equals to 4h. Here we'll add 4x to this equation, and we get that 169 minus 49 is 120, so in total this expression equals to 120 over 4. It equals to 4x plus 4h. Here we take 4 as a common factor from those two expressions, so inside the brackets we will have x plus h. 120 over 4 is 30, so in conclusion we found out that 30 equals to 4 times x plus h. Here we divide this equation by 2, and we get that 30 over 2 is 15 and 2 over 2 is 2. So in conclusion we found out that 15 equals to 2 times x plus h. So we write it down. 15 equals to 2 times x plus h. But again, 15 equals to 2 times x plus h. We'll divide this equation by 2. And finally we get that x plus h equals to 15. X plus h equals to 15. What is the length of line segment UN? For the drawing, it is very easy to see that UN equals to UO plus ON. Again, UN equals to UO, that is x, this is the radius of the biggest circle, plus ON, that is h. So in total, UN equals to x plus h. UN equals to x plus h. From one side, but from the other side, we've only found out that UN is the diameter of this circle that is equal to 2b. Look it again, we've only found out that UN equals to 2b. So you can write down that UN equals to 2b. UN equals to 2b. And from those two equations, UN equals to x plus h and UN equals to 2b, we will derive that x plus h equals to 2b. But we have already found out that x plus h equals to 15 over 2. Here x plus h equals to 15 over 2. So we can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b. We will derive that 15 over 2 equals to 2b. We divide this equation by 2, and finally we get that b equals to 15 over 2 is 15 over 4. So the radius of this circle b is equals to 15 over 4 units. And we already found out that the radius of this circle A equals to 2 units. So we can write it that A equals to 2. Our mission is to find out the ratio of B over A. So B over A equals to B, that is 15 over 4 over A, that is 2. 15 over 4 over 2 is 15 over 8. In terms of numbers, 15 over 8 is equals to 1.875. So we actually found out that the ratio B over A equals to either 15 over 8. In terms of numbers, it is equal to 1.875. And that is the answer to our question. B over A equals to either 15 over 8 or to 1.875. In the next step, I will summarize the lecture. In this lecture we found out the ratio between two radii, the ratio between the radius of this circle that is B and the radius of this circle that is A. Or in other words, we found out the ratio of B over A. So in the domain we have a big circle. Inside this big circle we have two small circles. Again, the radius of this circle is B, the radius of this small circle is A. In addition, we have inside this big circle the right triangle ABC. Actually, the right triangle ABC is partially located in the biggest circle. You know that the length of side AB is 5 units, side BC equals to 12 units in its length. This angle ABC equals to 90 degrees. And finally, we also know that AN equals to NC. Our mission is to find out the ratio of B over A, that is the ratio between the two radii. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. I'll try it again. According to the Pythagoras theorem in the right triangle ABC, AC square equals to AC square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So in total AC square equals to 25 plus 144. 25 plus 144 is 169. AC square equals to 169. We took out all of this equation and finally found out that AC equals to the square root of 169. It is 13. So the hypotenuse AC of the right triangle ABC equals to 13 units in its length. And because of the fact that at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. In total, AC equals to 13, therefore the first half AN must be equal to 13 over 2 and the second half NC must be also equal to 13 over 2. So here AC over 2 equals to 13 over 2. The first half is AN and the second half is NC. So in total you can write down that AN equals to NC equals to 13 over 2. This is the second half of the hypotenuse AC, that is 13 over 2. Then I presented to you rule number 8. And we implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. We have the right triangle ABC, and get ABC equals to 90 degrees. The length of AB is A, the length of side BC is B, and the hypotenuse AC equals to 3 units in its length. This right triangle ABC blocks this circle. The radius of this circle is R. According to rule number 8, you can find out the radius of this circle only by knowing the side lengths of the right triangle ABC that blocks the circle. That is to say, the radius of this circle R, will be equal to A plus B minus C over 2. Again, R, the radius of this circle that is blocked by the right triangle ABC equals to A plus B minus C over 2. We can implement rule number 8 in our drawing. In our drawing we have the right triangle ABC that blocks this circle. The radius of this circle is A. According to rule number 8, we get that A equals to AB plus BC minus AC over 2. Again, A equals to AB plus BC minus AC over 2. So A equals to AB, that is 5, plus BC, that is 12, minus AC, that is 13 over 2. So in conclusion, you can write down that according to rule number 8, the radius A of the small circle equals to 5 plus 12 minus 13 over 2. 5 plus 12 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So in conclusion, we found out that A, the radius of the small circle A equals to 2 units. We define the point of tendency of tangent AB with this circle as T. We define the center of this circle as P. We join points T and P together by a straight line. Point P is the center of this circle. Point T is the point of the circle itself. Therefore, PT is the radius of this circle. That is equal to 2. The radius PT is drawn to point T. That is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. BC is perpendicular to NP, then this angle equals to 90 degrees, and this angle equals to 90 degrees. So we actually found out that in the quadrangle PTBN we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the missing angle in total must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrangle TB and P, we have 4 right angles. Any quadrangle that has 4 right angles must be this rectangle, if not a square. So we relate to quadrangle TBBN as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, TP equals to BN, but TP is 2, therefore BN must be also equal to 2. Likewise, Pn in rectangle TPBN, Pn equals to TB, but Pn is 2, therefore TB must be also equal to 2. So here AB is 5, TB is 2, therefore AT is AB minus TB again. AB minus TB equals to AT. AB is 5, TB is 2, so 5 minus 2 is 3, so AT is 3. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point, point A. From the common external point, point A, we have two tangents to the circle, tangent AT and tangent AM. And according to rule number 2, they must be equal to each other. That is to say, AT equals to AM. But AT is 3, therefore AM must be also equal to 3. We have already found out that AM is 13 over 2, AM is 3. So AN minus AN minus AM equals to MN. Again, AM minus AM equals to MN. I will repeat again. Here, AN minus AM equals to MN. AM is 13 over 2, AM is 3. So this is 13 over 2 minus 3. Multiplied 3 by 2 and then we divide it by 3. We multiply it by 2 and then we divide it by 2 in order to account factor with 2. So it is 13 over 2 minus 3 times 2 is minus 6. So this is 13 minus 6 it is 7. So it is 7 over 2. So in total this expression equals to 7 over 2. So we actually found out that MN equals to 7 over 2. This line segment MN equals to 7 over 2 units in its length. We define the center of this circle as Q. We define the center of the biggest circle as O. Here, this is the center of the biggest circle that is defined as O. Then I presented to you rule number 7 and we implemented rule number 7 in our drawing. According to rule number 7, if two circles touch each other internally, then the straight line that connects their centers together must pass for their touching points. The center of the big circle is here at point O, the center of the small circle is here at point M. The straight line that connects the two centers together is OM. According to this rule number 9, the straight line OM must pass for point P. That is to say, OMP is one straight line. Again, OMP is one straight line. We can implement rule number 9 in our drawing. Why? Because in our drawing, we have the smallest circle touches the biggest circle at this point, point S. Point S is the point of tendency between the two circles. Actually, they touch each other internally. have internal edge between them at point S. Therefore, according to rule number 9, point O is the center of the bigger circle, point P is the center of the smaller circle. OP is the straight line that connects their centers together. According to rule number 9, the straight line OP must pass through point S. That is to say, OPS is one straight line. Okay, OPS is one straight line. So you can write down here that OPS is one straight line. OPS is one straight line. Okay. If OPS is one straight line, it means that OS minus PS is PO. Again, OS minus PS is PO. OS minus PS is PO. What is the definition? Again, if OPS is one straight line, then OS is also a straight line. So OS is a straight line. What is the definition of the straight line OS? Line segment or the straight line OS starts from point O, that is the center of the biggest circle, and then to point S, that is the point on the biggest circle itself. Therefore, OS is the radius of the biggest circle that is equal to X. So you can substitute OS here by X. We already found out that SP is the radius of this circle that is equal to 2, so you can substitute SP by 2. Okay. So in total we found out that PO equals to X minus 2. Here PO equals to X minus 2. Then extended the perpendicular ON by straight line to this point OT. Extended the straight line ON by straight line, therefore OT is a straight line. If you focus on this side of the straight line OT is point N, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So each angles we have in this side of the straight line OT is point N, we have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees according to the rules they mentioned. So therefore the missing angle must be equal to 90 degrees. We know that AC is tangent to this circle at point M. We join points P and M together by a straight line. Point P is the center of this circle, point M is the point of the circle itself, therefore PM is the radius of this circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. And whenever your radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Then we did the construction. We drew perpendicular on the radius MP at point P. Again, we drew perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. So inside quadrilateral M and TP we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral PM and T we have 4 right angles. Therefore quadrilateral PM and T is a rectangle. We know that the opposite sides of the rectangle are equal to each other. That is to say PM equals to Tn. But PM is 2, therefore Tn must be also equal to 2. we define the length of NO as h. In rectangle MN PT, MN equals to PT, but MN is 702, therefore PT must be also equal to 702. Then we implemented the Pythagoras theorem on the right green triangle POT. According to the Pythagoras theorem in the right triangle POT, so first of all, here TO equals to Tn plus NO, that is to say TO equals to Tn, that is 2, plus NO, that is h. So in total TO equals to 2 plus h. We have already found out that PO equals to x plus 2 and PT equals to 702. Repeat again. PO equals to x minus 2. The total PO equals to x minus 2. We already found out that PT equals to 702 and OT equals to h over h plus 2. According to the Pythagoras theorem in the right triangle POT, PO square equals to PT square plus OT square. PO square is PO is x minus 2, therefore PO square is x minus 2 square, and it equals to PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, plus OT square. OT is h plus 2, therefore OT square is h plus 2 square. Then we open the brackets on both sides of the equation and found out that x minus 2 square equals to x square, that is x square plus 2 square, that is 4 minus 4x. And it is equal to 49 over 4 plus h plus 2 square. H plus 2 square equals to h square plus 2 square, that is 4 plus 4h. So in conclusion, we found out that x plus 4 minus 4x equals to 49 over 4 plus h square plus 4 plus 4h. And then we joined points O and C together by a straight line. What is the definition of the straight line OC? The straight line OC starts from point O, that is the center of the biggest circle, and then to point C, that is the point of the biggest circle itself. This is exactly the definition of a radius. So OC is the radius of this circle, that is equal to x. ON equals to h according to our definition, and we already found out that NC equals to 13 over 2. So this is the right triangle ONC that I copied from the original drawing. ON equals to h, NC equals to 13 over 2, and therefore OC equals to x. According to the Pythagoras theorem, OC square equals to ON square plus NC square. OC is x, therefore OC square is x square, and is equal to ON square. ON is h, therefore ON square is h square, plus NC square. NC is 13 over 2, therefore NC square is 13 over 2 square, that is 169 over 4. So in total we found out that x square equals to h square plus 169 over 4. Therefore we can substitute x square in this equation here by h square plus 169 over 4. We did it and we got here that x square is h square plus 169 over 4 plus 4 minus 4x equals to 49 over 4 plus h square plus 4 plus 4h. Here we have h square on both sides of the equation, so h square we get cancelled. And we also have 4 on both sides of the equation, so 4 also we get cancelled. So in total we left only with 169 over 4 minus 4x, that is equal to 49 over 4 plus 4h. We subtract 49 over 4 from this equation, we found out that 169 minus 49 over 4 minus 4x equals to 4h. We added 4x to this equation and found out that 169 minus 49 is 120, so in total this expression equals to 120 over 4, that is equal to 4x plus 4h. Here we took 4 as a common factor from those two expressions, so inside the brackets we left only with x plus h. So this expression in total equals to 4 times x plus h, and 120 over 4 is 30. So in total we found out that 30 equals to 4 times x plus h. Then we divided this equation by 2, 13 over 2 is 15, and 4 over 2 is 2. So in total we found out that 15 equals to 2 times x plus h. Yeah. 15 equals to 2 times x plus h. We divided this equation by 2 and finally found out that x plus h equals to 15 over 2. What is the length of this line segment UN? From the drawing it is very easy to see that UN equals to UO plus ON. So UN equals to UO, that is x, that is the radius of the biggest circle, plus ON, that is h. So in total UN equals to x plus h. So we can write down here that UN equals to x plus h from one side, but from the other side we have already found out that UN is the diameter of the circle that is equal to 2b. UN equals to 2b. So you can write here that UN equals to 2b, and from those two equations UN equals to x plus h and UN equals to 2b, we will derive that x plus h equals to 2b, x plus h equals to 2b, but we already found out that x plus h equals also to 15 over 2. So we can write here that x plus h equals to 15 over 2, and from this equation 15 over 2 equals to x plus h equals to 2b. We will derive that 15 over 2 equals to 2b. 15 over 2 equals to 2b. We divided this equation by 2, and finally found out that b equals to 15 over 2 over 2 is 15 over 4. So the radius of this circle B equals to 15 over 4 units in its length. We have to find out the ratio of B over A. B equals to 15 over 4 and A equals to 2. So in total B over A equals to 15 over 4 over 2. 15 over 4 over 2 is 15 over 8. So in total we found out that BA equals to either 15 over 8. In terms of numbers, B over A equals to 1.875 units. I repeat again, the ratio of B over A, that is the ratio between the radii of those two circles, equals to either 15 over 8. In terms of numbers, it is equals to 1.875 units. Okay, thank you very much.